2, 3, funky.
Hey you guys, welcome back to my channel, and in today's video I'm going to be going over Newton's third law, and we're going to be wrapping up the Newton's laws of motions in this video. And I hope you guys are having a good day, by the way, and yeah, let's just get started. So basically the whole big idea of Newton's third law is basically the law of action and reaction. And so for every force there's an equal and opposite force. For every action force there's always a reaction force. They're equal in strength and opposite in direction. They're equal in magnitude but opposite in direction. So you guys see how most of the words that I highlighted basically state the same thing, that's equal and opposite, equal and opposite. Get that in your head because that's basically the whole entire point of the law, I guess. So basically, so for it, I just feel like it's very repetitive, but yeah, it's just everything is equal and opposite. So it's going to be the same amount of force, so equal forces every single time, but it's going to be in opposite directions, or it wouldn't even be able to exert forces on each other. So you can't really have a pair of forces that are in the same direction. So basically they're just going to be equal in the amount, but opposite in the direction, if that makes any sense. We're going to get more into it, so don't worry about it. And so for every action force, there's always going to be a reaction force, or it's not going to even happen. And so it's also known as the law of interaction or the law of action-reaction. So the force is an interaction. So force involves the interaction of two objects, and an interaction is a mutual action between one thing and another thing acting simultaneously. That's a big word. But yeah, there has to be two different objects that are interacting with each other to for force to happen. So the force is always going to happen in pairs, and I think I've gone over that, but yeah. And they have to happen at the same exact time. That's another thing. They have to happen at the same time. Okay, so here's just some like thinking where we just kind of like put this into the real world and we kind of just like think about it. So when you push on a wall, you see how you don't fall through the wall. That's because you and the wall are now a pair of forces and you're acting upon each other. As you're pushing on the wall, the wall is going to be pushing back on you. And the wall wasn't pushing back on you, you would fall right through it because it's not pushing back on you. And it might not make any sense, but that's just the way it works. So you and the wall interacting with each other is a pair of force, and you're both pushing on each other the same exact amount of force, and you're both opposite in direction because you're pushing on the wall maybe to the right and the wall's pushing back on you to the left. So just think about it. A hammer and a nail. If you're trying to hammer a nail into a wall, the pair of forces acting upon each other would be the nail and the hammer. So as the hammer is pushing the nail into the wall, the nail is going to be pushing the hammer, which is why you get kind of like a force that kind of holds you back. So you get kind of like you know how you push on the hammer and you kind of like stop because like it hits back? It doesn't really make any sense, but like when you hammer the nail into the wall, it kind of just like pushes back. So the hammer pushes on the nail and the nail pushes on the hammer. Oops. Okay, so here's just some basic notes to self, I guess. So an object cannot contain or possess force. That's just something. For example, like a dynamite, I'm trying to remember what a dynamite is, but a dynamite, I think it blows stuff up and stuff like that. So basically a dynamite cannot contain or possess force, but it can exert a force on another object. So I think it blows things up. So if you were to like throw a dynamite onto, I don't know, a building or whatever, it can exert a force when they both come in contact, but a dynamite itself cannot contain or possess force, and that goes for every object. It can only occur between two pairs of forces, and they can exert force on each other, but they cannot possess a force by itself. So force cannot be possessed. It can only be exerted onto other things. I hope that makes sense. And also, it doesn't matter which force you call the action or reaction force. So the hammer with the nail example. So a hammer pushing into the nail, that could either be called the action or reaction, and vice versa. Yep. Okay, here are some examples, some more like real life examples. Okay, so a foot pushes down and back on the floor, and the floor pushes up and forward on your foot. So basically you're walking and the floor is going to be pushing back on you like you're pushing on the floor, or you would fall through the floor. Car tires pushing against the road and the road is pushing back on the tires, or the car would fall through. When you're swimming, you push the water backwards and the water pushes you forward, which allows you to move. And you guys see how I highlighted some words where they're basically the opposite. So it's going to be the same exact force, but they're going to be opposite in direction. So you're pushing water backwards, water's pushing you forward, and so on. Okay, some more examples. So when you're trying to identify the pairs and how to name them, all you have to do is reverse it. So if the tire's pushing on the road, that means the road is pushing on the tires. If the earth is pushing on the ball, then the ball is also pushing on the earth. So all you have to do is identify your first pair, and you just have to reverse it, and that's your other reaction pair, or whatever you try to name each one. So you could name road pushes tire as action, and then tire pushes road as reaction. It doesn't really matter. Yeah. As long as they're both two pairs of forces that are directly acting on each other simultaneously. And okay, let me go. Should I go back? I don't know. Let's go back. Okay, let's go back. So basically, the only here's some like misconceptions or like wrong ways to name the pair of forces. So basically, if you were to say, hold on, let me think for a second. Okay, here's a test problem that I got wrong. Well, I didn't get it wrong, but I had it wrong at first, and my friend explained it to me. So basically, if you were to say that you were pushing a box, if you were pulling a box with a rope, and they're asking you what the pair of forces occurring would be, you wouldn't say that you are pushing the rope and the rope is pushing on you, because what is happening is you are pulling the box and the box is pulling you. So it doesn't matter what's in between that you're using to pull it. The forces are occurring between you, your hand, and the box. So you're pulling the box, but you're just using the rope. But the action, the pairs of forces that are occurring is between your hands and the box. So you're pulling box and box is pulling you. I hope that makes sense. Okay, now we can move on. So basically, here are action-reaction forces on different masses. So if you were to exert a force on a small mass, it would result in a greater acceleration compared to if you were to exert the same force on a larger mass. And think about it, because this actually really makes sense. If you were to push a let me think. I'm so bad at examples. If you were to push a car compared to you pushing a bicycle, obviously pushing a bicycle might not be as easy, but it is going to accelerate way more than if you were to try and push a car. You probably wouldn't even be able to push the car, because that's how heavy the mass is compared to a bicycle, which has a way smaller mass. So it would be easier for you to get the bike moving and get it to move way faster than you moving the car. So that's basically the whole logic. So a greater force gives you less acceleration. No, not a greater force. A greater mass gives you less acceleration. So the bigger the object is, the less it's going to accelerate. Because acceleration and mass are inversely related to each other. And force and acceleration are directly related to each other, because the more force you put, the more acceleration. And the formula for acceleration is net force over mass. And so you guys see how I made this capital letter and this small letter. Do not make your acceleration capital letter, because that represents something else in physics. But for the purpose of me trying to explain this to y'all, I made a capital letter. So if you were to try and move a cannonball, you know how the mass is way smaller compared to the actual cannon. So the same force, but the cannon weighs a bigger mass, and this one is smaller, which is the letters and stuff. You guys see how the acceleration is bigger for the cannonball with a small mass, and it's the mass is bigger with a small acceleration for the cannon. You see what I'm trying to get at right now? So a bigger mass is small acceleration, and a smaller mass is bigger acceleration. Okay, here's some reminders before we close out the video. Action and reaction forces do not cancel each other out. and that's just something that people get confused. So just because they're equal and opposite does not mean you're going to cancel each other out, because you could be thinking, okay, so if I push on the wall with 20 newtons, that's the amount of force, that's how force is represented with newtons, and then the wall pushes back on me with 20. If it's opposite and equal in forces, then it should be -20 because of the direction. So they're gonna be like, isn't 20 minus 20 0? But that's not how it works, and don't ask me, that's just how physics work, I guess. But it doesn't cancel each other out, or I don't think there would even be any force occurring. I don't know, but it doesn't cancel each other out. Okay, they're equal and opposite forces, and that's basically the whole idea of this law. So yes, and there's always going to be two pairs of forces, and yes, that's the end of the video. Thank you guys so much for watching. I hope this video actually helps you out, and I hope to see you guys in the next one. Bye guys.